The next thing that we're going to talk about with probability is if we are doing two events. Okay, so something like flipping a coin twice, or flipping a coin and rolling a dice, or drawing out a red marble and then drawing out a blue marble if you have a bunch of marbles in a jar. So things like that. So when we talk about independent and dependent events, it's when more than one thing is happening. So we say that two events are independent. Sorry about that typo. Oh, that's really bad now. There we go. Independent if the first outcome, or the outcome of the first thing, of first event, does not affect the outcome of the second. Oh, we missed a no. The outcome of the second event. Okay, so this would be things like flipping a coin twice. Whatever you flip the first time, it doesn't affect what happens the second time. Rolling a dice twice. Whatever you roll the first time, it doesn't have any effect on the next thing. If you draw a card out of a deck of cards and then put it back and draw another card, that would be another independent event. So to find probability of independent events, like the probability of flipping a heads and then another heads, you just take the probability of the first event times the probability of the second event. We say two events are dependent if the outcome of the first does affect the outcome of the second. So if you were going back to that deck of cards, if you draw a card out and then keep it and draw another one, that changes the probability because you have taken a card out and kept it, so the probability is not the same. So to find the probability of like drawing a king and then drawing another king, so it's still the probability of the first event times the probability, we read this as the probability of B given A, which is easier. It's easier to do than actually explain, but you have to kind of take into account that the first event has already happened. So let's do a couple examples. We have a bag. It's got 12 red marbles, 9 blue, and 8 green marbles. And we're taking marbles out at random and not replacing them. We want to know what's the probability that both are red. Since it is not replaced, this is a dependent event. Okay, what you draw the first time is going to have an effect. So the probability of drawing red on the first one is, how many marbles are in here? 29. It's a weird number of marbles. Okay, so there's 12 red ones out of 29. Now, let's say I drew one. I picked a red one. I have a red one in my hand. Now, there's only 28 marbles left in there, and I want to know the probability of drawing a red one. Remember, I already have a red one in my hand, so now there's only 11 red ones left in the jar to pull out. Oh, it's a bag, whatever. So we multiply those two things, reduce it, all that good stuff. We get 33 out of 203. That's the reduced version of it, which is about 16%. That's got a lot of control. All right, what's the probability that both are red if they are replaced? So I pick a marble out and then I put it back and then I draw another one. Since I'm putting it back, we have now gone into an independent event. So the probability of getting a red on my first one is still 12 out of 29. And then I put that red one back. So on my next draw, I still have a 12 out of 29 probability of pulling that red one out. So if I multiply those, I get 144 over, get your calculator to help you, 841, which turns out to be about 17%. So that's all the math involved with this. On the back side of your notes are just some practice problems that I'll kind of walk you through. If you'd like, I would suggest maybe trying some of them out on your own and then watching the video. It might be a good way to learn and get a little practice.